All right. Happy Friday, and thank you for joining us. Welcome to Webcast Friday. Before we get into this, I'd like to take a minute or two and just let you know what Webcast Friday is and who we are. My name is Chris Armstrong, and I am the multimedia manager here at InterWorks. And InterWorks is a people-focused technology consulting agency based in Stillwater, Oklahoma. We have offices in Oklahoma City, Tulsa, Chicago, New York, San Francisco, Christchurch, London, Germany, and the Netherlands. Webcast Fridays are 20 to 30-minute presentations that show off some of the more interesting work that we do and that we hope you find informative and inspiring. We will have a Q&A time at the end, so feel free to use the Q&A button if you are joined via Zoom, and we'll get to those at the end. Webcast Fridays happen every other Friday, so if you're interested in those, you can go to interworks.com/events. So let's jump into it. Today we have Brad Fair, one of our solutions architects. Brad has been with InterWorks for a long time and is one of those people most passionate about Tableau Server and server-based technologies around here. So I'm excited that he's here today. Brad, it's all you, buddy.
Hey, thanks, Chris. So as Chris said, I'm Brad Fair. I'm a solution architect with InterWorks. And I don't know how many of you know, InterWorks started out as an IT company. And I started here when we were only an IT company. I say only with little bunny ears there. So I predate our business intelligence practice here, which is kind of fun. Got to see that grow. As soon as I realized what was going on in the world of Tableau, I decided that I would jump from our IT side to our business intelligence side. And so just some quick background, I consider myself, having done that, a recovering IT guy. But before I came to InterWorks, I was a network administrator for an internet service provider. I worked for Dell in their enterprise server support. And then when I came to InterWorks, I focused on storage, server virtualization, disaster recovery, and then really all throughout my 16 years of IT and technology, I have done software development. So none of this is really important except for two things that I'll call out. IT people can come to love Tableau. So for those of you that have that concern, it's possible. I'm proof of that. And then the second thing is I like fast things. I've always liked fast things, especially when it comes to technology. And so that is exactly why we're talking about Tableau Server performance and scalability. So what are we going to cover over the next 20 minutes or so? We're going to talk about what servers are and what can make them slow. There are only a few things, thankfully. We're going to talk about what can make Tableau Server slow specifically. I'm assuming since you're joining Tableau Server performance and scalability, you care about Tableau Server performance. Then we're going to talk about what do we do to make Tableau Server fast, which is, there's more to talk about there than I have time to talk. So I'm going to leave you with some resources on that. And then lastly, one of the most fun conversations I have frequently is all about load testing. And then with load testing comes load testing gotchas. So let's dive into what is a server and what could make it slow. Fundamentally, a server has four things that it does for us, and we call these the four core resources. So for those of you that are in IT, you're familiar with these, especially as they relate to virtualization. Fundamentally, a server provides us the ability to process, crunch numbers. What good is a server if we can't crunch numbers anyway? We have to get that data from somewhere, and we like that somewhere to be fast, and so we have memory. And memory is extremely fast, especially when you compare it to disk. But the problem with memory is when you unplug the server, whatever's in the memory goes away. So we also need a way to persist that data, which is what we use disks for. And on this, there are two things that I talk about when I talk about disks. So there's the bus speed, that is how fast we can get the info out of the disk and to the processor. And then we also have the disk itself. Does it spin a spindle, or is it solid state or flash or any of those other things? Each of those impact disk performance. And then lastly, crunching numbers and storing data does us no good at all if we can't serve that to other people. That's why we call it a server after all. So we need a network. And these 4 core resources here are the physical places where when something's going slow on your server, you'll find the cause. So when I talk about Tableau Server performance and scalability, I'm talking specifically about looking into these 4 core resources, finding out what sorts of issues you might have with them, and then hunting that down and resolving the issue. A thing I'll note is you can only ever have one bottleneck at a time. So when you're looking at these 4 core resources, only one at a time can be slowing you down. If you are running into performance issues, your job is to track that one thing down and fix it. That doesn't mean there's not another thing. You might find another bottleneck right after your first, but we can only ever hunt one down at a time. And from that perspective, now we need to know a little bit more about Tableau Server and what is in Tableau Server, because these are the things that could cause that contention. So there are lots of processes in Tableau Server. For those of you that haven't joined me in my Tableau Server architecture classes, you'll know that this is one of the things I'm most passionate about. Talking about each of these, what they do, how they perform. I'm going to give you the abridged version, and hopefully you find it helpful. So just a quick run through of what these are. We have the licensing service, which is responsible for making sure each of the licensed processes are properly licensed. We have the cluster controller, which is responsible for managing the services on any given node in a cluster. And if you're on a single node environment, you still have it, but it doesn't do as much for you as it would if you were in a cluster. The cluster controller also handles some repository failover tasks. We have the coordination service, which is responsible for communication between some server components. And it's also responsible for making sure you have a quorum so that you know if you have multiple nodes in an environment, how many could fail and you still be up and running. Then we have the gateway, which is what every client who connects to Tableau Server communicates through. So the gateway is going to receive the piece of traffic and send it on to the correct process in order for you to process it and get whatever results back you're looking for. We have the search service, self-explanatory. The VizQL server, this is the process responsible for rendering your visualizations. So its job is to go look in the database, the Tableau Server database, and figure out what viz you're getting, what query it needs to send, and then it's going to send the query, get the results back, perform secondary results, or calculations rather, and then render your visualization for you. So when your end user gets Tableau Server and or gets onto Tableau Server and opens up a viz, they're most interested in this process because they don't care, to be honest. But as an architect, you're probably most interested in this process from a viz standpoint. We have the application server, which is the web interface that people browse around. The backgrounder, which is responsible for background tasks, the most notable of which is Tableau data extract refreshes. We have the cache server, which is a query cache. So if you have, I know none of you have slow databases, but if you did theoretically have a slow database, then the query result would be cached after that first poor soul who waits for the query. And each subsequent soul would get that data faster because it'll just go to the cache. We have the data server, which is about data sharing, and the data engine, which is for Tableau data extracts. Extracts are fast, they're in memory, and it's a good way for you to not send a bunch of traffic to your database and have DBAs knocking down your door. The data engine process is married to the file store process in as much as they can't be separated, they have to exist together, and the file store is responsible for storing files, specifically extracts. Then we have the repository, and this image, it's active repository. In a Tableau cluster, we can have a passive repository as well. This is a Postgres database, which is responsible for all of the data that, that goes into Tableau Server, the application. Now, this isn't the data you're analyzing, but it's data like which users are on Tableau Server, whether they're licensed properly, historical information, and so on. So a lot of things, I don't expect you to remember this or have perfect recall, but there are a few of these that are kind of a big deal. And so I'm just going to call those out. these are the processes that will consume some of those 4 core resources. And so generally, if you see that you've run out of processing power, for instance, some of these processes could contribute to that. So let's look at each of them, these kind of the big deal ones. We have the VizQL server. The VizQL server, as I said, is responsible for going to look at the viz to figure out the query, executing the query, managing the result set, performing secondary calculations like table calculations and so on, and then actually rendering the viz, kind of a big deal. The VizQL server can consume a significant amount of memory and processing power, depending on its workload. So just be aware that those are the resources you'll find they consume. They don't tend to consume network, they don't tend to consume disk, but memory and processor, absolutely. We also have the data engine. The data engine is responsible for, let's say, loading your Tableau data extract from the disk into memory, and then providing some interface for you to query that. After all, you do need to query that data. And because it's pulling what could be a large amount of data into memory, we find that we can get memory constrained. We also have the opportunity to be processor constrained if your extracts are wide or have high cardinality, a lot of different things within columns. Then it could do a lot of processing to try and sort those result sets so that you can pull them out and use them in your viz. You can tell because repetition here, memory is kind of my #1 concern with the data engine though. The backgrounder, of all of these processes, the backgrounder is sort of the most adept at consuming all resources. Now I'm going to put an asterisk on this, perhaps not literally on the slide, but it can consume all of your memory because it's 64-bit. And if your result sets are large, you should consider that it's going to take a lot of memory. It doesn't just need your result set in there once, it needs it in there twice. The first will be the way that it comes from your database. The second time that it's going to be in memory is going to be that sorted and optimized version that Tableau will eventually write to disk and call an extract. It can consume a lot of network. If your query is large, it's got to get those results from your database server. And it can consume a lot of disk as well. Disk performance and disk space, less disk space than performance, as it writes those extracts down to disk. If your extract is large, that write operation might take a little while. So when I say all of the things, those are the 3 big ones. And then, of course, there's the processor. The one thing about this is the asterisk I was telling you about. The backgrounder is single-threaded. It can only do one thing at a time, and it's blocking as well. So, as it's waiting for the query results to come back, it's not going to go try and do another task. So if it's doing all of its calculations, the worst case scenario is it'll only ever take up 1 core of your processing power. So when I say all of the things, I mean it, but kind of all of 1 core of your processing power. Now, if you have multiple backgrounders doing each their own task, it could consume the entirety of your processor. If you have as many backgrounders as you have cores, that's a thing that could happen. And then we have the repository. I told you this is a Postgres database. There's no difference between this and any other transactional database. Its performance characteristics will be very similar. So it can consume a significant amount of processing power and disk performance as well. I don't tend to see this, but I do see it in large environments or environments that are under extreme load. So those are things that you can watch out for. The other processes may perhaps consume some or potentially a little more than some of your resources. But in my experience, they haven't been problems for me. And I've load tested a lot. I've done a lot of analyses around these. These tend to be the big ones. So what causes these to be big resource constrainers? Your workbooks. At the end of the day, Tableau is built for you to help see and understand your data. And so we're talking about workbook design. That's what's going to consume most of your resources. If, for instance, you decide you want the mother of all dashboards, and you build this gigantic crosstab that's got hundreds of millions of records in it so that you can see all of your company's data all in one screen, that's likely to be difficult to render. So there goes your processor, right? it's likely to be a lot of data that it's supposed to store in memory. So there goes your memory, and it could be a data extract, and so you might have a lot of disk space that you're consuming, or disk performance issues as you read that off of disk. Now that's like worst case scenario, but when I go in and do a performance test in an environment, or try and talk with people about what's slowing their environment down, it's always a conversation about optimizing workbooks. Very rarely does it have anything to do with the actual server itself. So what are different ways that you can optimize workbooks? Well, you can prep your data, prepare your data to be used in your analysis. So what's this mean? Let's say that you have 10 sales at your company every second. Each day, that amounts to a lot of sales that you're going to have in your database. So if you're trying to do an analysis against that data, but you're only ever looking at monthly patterns, then when you create your workbook or your extract, you should not be using a transaction level of detail. Aggregate if you can. Also, if you're doing calculations like, if you're over 10 sales, that's great. If you're, let's say, 10 sales a second, that's great. If you're below 2 sales a second, then that's a problem. If you want to create a field, a calculated field that tells you that, then you should watch out for the type of column that's going to be. So is it going to be a number? Is it going to be Boolean? Is it going to be a string? I think most people are drawn to making it a string when they're building KPI calculations like that. So if greater than 10, good. If less than 10, bad. The problem is it's got to materialize that string in memory a lot of times in order for you to actually have a look at that. So those strings can be inefficient. Whereas what you could do instead is just make it a binary calculation. And it'll return true and false, which is significantly more efficient than strings. I remember having one client that had a calculated field that output strings, and one of our consultants looked through that, optimized it to output numbers instead of strings, and it drew the query down from 27 seconds to 3 seconds. So prepping data is important. Optimizing calculations. Anywhere you can sort of remove unnecessary logic, you should remove unnecessary logic. Watch out for things that are row-level calculations. If it has to be, then so be it. And really, to that end, you could put it in your data so you're not doing row-level calculations in Tableau. Just prep the data with that. But do aggregate calculations if it makes sense. They can be calculated on the fly, hopefully efficiently, and so you don't have to worry about reading a bunch of data off of disk in a slow manner. You should also take steps to reduce the number of queries you're sending. So back to this hopefully fictitious example of the mother of all dashboards. When I see those, theoretically, right? When I see those, I see people with 15 different quick filters on that dashboard. And each one will send a query to the database as they're changed. And then if those quick filters are set to only relevant values, that is showing you the value for one field based off of what another field has been set to, then your queries get to be more complicated and potentially could run in a sequential manner, which is going to slow you down. So you should take efforts to reduce the number of queries that you have in your workbook. Now, this is beneficial because if you take concerted efforts to do that, you're likely to find a dashboard that's much more efficient, that tells a cleaner story, that looks better, and so on. So it's all around a good idea. Trying to see if there's anything else that I'm missing here, but I don't think so from an optimizing workbook perspective. There is one thing that I always tell people here. Optimizing your workbook is fine and dandy, but if you take something away that reduces your business value to where the workbook is useless, put it back in. I won't get on to you, even if it's a slow running workbook. If you're getting your value out of it, then by all means do that. Don't let some Tableau Server geek tell you that you should change the way you conduct your business if you're doing well with it. So we talked about optimizing workbooks. Now, the next thing I want to talk about is how do you identify those workbooks that might need optimized, for instance? Or even if you've done the optimizations, then how do you know how many users can fit on your Tableau Server environment given your super optimized workbooks? I always come to the same thing, load testing. Why is this going backwards? Let me fix this. Yep, we've already optimized workbooks, and now we're at load testing. So load testing, I think, is a really good way to understand your environment and its constraints and parameters quite a bit better. So when you do load testing, what you should do is set up monitoring of your Tableau Server environment. You need to go capture statistics about the 4 core resources. And I do this with perfmon, and actually InterWorks has built a tool that will do this in our Power Tools suite as well, which I think is a phenomenal utility. It saves me a lot of time. So I set up perfmon. I make sure I'm also looking into the Tableau Server repository for information to record statistics. And then once I have the monitoring set up, I will generate a load with a program, not people. I have people that say, well, we'll just load test with, we'll sit 10 people down and have them try and hammer the Tableau Server environment. What good is that going to do you? If you have 10 people sitting down trying to hammer your Tableau Server environment, they're probably going to break your Tableau Server environment. And from that, you're not going to get any idea of how many normal users you're going to be able to have on your environment, because they were not being normal users when they were doing your tests. So what I recommend doing is watching your normal users, see what they do, write down their steps, and then automate those steps, and then spin it up. If you want more normal users than you currently have, then generate that load as if you've added more normal users. And then once you've built this load, you need to analyze your results. See if you can look back at the 4 core resources and find out where that contention is. When the contention showed up, which workbooks were loading slowest? Those are likely to be the ones that you need to focus on. So load testing for me exposes those weaknesses and helps you figure out why exactly they're there. Now, when you set up monitoring, you should be able to do that per process so that you can see, is it slow because my extract is too wide? You'll find that in the data engine. Is it slow because the visualization is too complex? You're going to find that inside the VizQL process, if that's the case. Is it slow because the workbook is so gigantic, it took forever for me to extract it from the repository? Well, you're going to find that in the repository. So when you're analyzing for contention, it begins to tell you the story of what is going wrong. Now, every time I load test, I got to tell people about the gotchas. So here's the deal. Users behave differently. Users behave differently than all other users in your environment. You might have some that just go look at a viz. You might have some that go look and interact. You have heavy users and light users. So be sure to account for those. You also need to be able to account for your load testing to be your point of contention. So if you want to simulate 1,000 users, you're not going to be able to do your load test from a normal laptop. You probably need a pool of servers conducting your load test, because 1,000 users is not lightweight. So watch out for your servers. You may need to have multiple servers for load testing. And then what happens when you don't find contention, but you still have slowness? Those sorts of scenarios are always logic issues. And these logic issues can be things like exhausting a connection pool. They can be things like a database server queuing for you, or a number of other blocking issues. So if you find when you do your load test that workbooks are slow and you don't have contention, we're going to look into potential logic issues, which you tend to be able to resolve those with workbook design changes. There's one other thing that I didn't get to add to this, and that is wait times. So when you are doing load testing, you need to account for the different wait times that your users might have. So what do I mean by that? Well, for instance, when a user navigates to a viz, they're going to spend a little bit of time looking at it. They're not just going to go to the viz and immediately click a filter. Now, occasionally, you might have someone that clicks a filter within a second or two, no big deal. But then after they get their results back, they're going to spend a few seconds, a few minutes to look at it. So when you're conducting your load tests, you need to account for that wait time. And you should be measuring what the normal wait time is and accounting for that. Because if you think it's 5 seconds, you might be surprised to find it's really 2 or 3 minutes. And this makes a drastic difference on how many sessions you can have on your Tableau server at any point in time. So I know it's been like a lightning round here, but I'll do a quick recap. First, server only does 4 things for us. It does processing, stores things temporarily in memory, stores things permanently on disk, and sends things so that other people can benefit from them over the network. We talked about the different processes and what they do. We talked about which ones normally cause contention, how to find that contention, and how to resolve it by working through workbook changes. Now, all of these things seem simple, but don't let that mean that you want to ignore them. If you find a simple change you can make in your workbook, like turning a KPI calculation from strings as an output to a Boolean as an output, then you should do that. It will save you time and it will perform well. So as Chris said, we're going to open this up for Q&A, but I'll tell you, and especially for you folks that join this recording after the live session, send me an email, brad.fair@interworks.com, and I will send back to you a Tableau scalability white paper. This is on Tableau's own website, but it's one that I and two other coworkers authored as a result of a lot of the large installs that we've done. I'll send you this slide deck with notes, and then I'll also send you a link to a Tableau performance checklist that tells you a bunch of different things you can do inside of Tableau Desktop to make sure that your Tableau visualizations are as fast as you can make them. So with that said, thanks for joining. I appreciate the time you spent with me here, and I will open it up to questions. For those of you that do have questions, you're welcome to type those into the Q&A window of this webinar. Well, looks like we may be all Tableau Server performanced out. No questions to speak of at the moment. So for those of you that join later, and for those of you that are here now, if you have questions later, feel free to email me. Again, I can be reached at brad.fair@interworks.com.
Brad, I think you explained it well enough that there are no more questions.
Oh, thanks, Chris. Maybe.
I do appreciate you being on, and for those of you still watching, this will be up on our website if you want to watch it again, or if you want to send it to a coworker or a friend or somebody that you feel that needs this information. interworks.com/blog. It should be up there hopefully by the end of the day, if not Monday at the latest. So I appreciate you joining us, and check back in for our next Webcast Friday, 2 Fridays from now.